If you're watching, you can ask questions. You can post your queries. If you need any clarifications, please do post your queries. Purnima, good afternoon. So there is, there is no hard and fast rule for finding the value of n. It will depend upon the computational accuracy that you want. So the simple formula is n equal to b minus a divided by h, where h is a step size or width. Now, having as much n as possible is good for the accuracy, but it depends on your computational power, on your the kind of computer that you are using. So, but say if you are not too sort of fussy about the accuracy, then a moderate n would be fine. I mean, which is the number of intervals that you want to take. So, say in a say unit h, say for example, so a b minus a is taken as say some n units. So, if within 1 unit, maybe 5 to 10 h would be good. Relative percentage error is obtained by the actual value minus the obtained value divided by the actual value multiplied by 100. So that's the relative percentage error. Relative means that you are taking it relative to the actual value. Sometimes the actual value is available, sometimes it's not available. But in these situations where we are talking about a course, in that most of the time we are able to either determine it exactly using say an integration or differentiation and so on. So that's what the relative thing is. So relative is say the magnitude of the actual value minus the obtained value. Now, as I said, it's a magnitude, so it doesn't matter which one is bigger. So you take the magnitude, that's the value of it, divided by the actual value and multiply it by 100. That will be giving you the relative percentage error. Any other question? double integral using trapezoidal rule. Let me just check. It's not at the top of my head. Let me just check and see whether I can answer your question. So let me give you an example. This is from the internet. Can I get this pen? Okay. Okay, so this is just like a composite. So this is like a 0 to half and a 0 to half. There's an exponential y minus x, and there's an integral over both, so dy dx. Okay. So let's take n equal to 2 between 0 and half. So then the a b f of x dx is equal to h by 2 f of a plus twice of the average of the 2 plus f of b, where, as I said earlier, h is equal to b minus a by n. Your h here is equal to half minus 0 divided by 2, which is equal to 1/4. So this thing simplifies for the first integral to be f of x dx is equal to 1/8 f of 0 plus twice of f of 1/4 plus f of 1/2. And so now again we use this for the second integral, which is 0 to half, and now the integral of this thing. So where g of x is equal to 0 to 1 0 to half, this 0 to 1 actually, exponential y minus x dy. Okay. So then you can write down the composite integral as this is like your 0 to half and a 0 to half exponential y minus x dy dx is equal to 0 to half g of x dx, and this is equal to again 1/8 g 0 plus twice of g 1/4 plus g of half. So what I mean to say here is that now you can follow this thing. So what I mean to say here is that if you have multiple integrals and if you want to apply trapezoidal rule or Simpson's rule, whichever rule you want to apply, first do one integral just like as if you're doing a single integral, and once you're done with that integral, you're still left with one variable, and then again do that, apply that same formula for the second integral with all these simplified things coming down from the first integral. So it's like applying the same formula twice every time, thinking that you're doing a single integral. Okay, so that's how you do it. I hope this thing is clear, that we are just talking about two integrals to be done one after another, and applying the same formulas that you have applied for getting these values for the integrals. Others also, please ask questions if you have. Selvaraj, there are many ways numerical solutions help in chemical engineering. You have all these chemical reactions, which are essentially first order or second order differential equations, or even more complicated than that, could be third order or fourth order differential equations. And these equations cannot be solved analytically at all time to find out the concentration of one of the ingredients and so on and so forth. Then there are finite element methods that are used. So all these things you have to solve numerically, and in order to solve numerically these equations, treat them as if you are solving a first order or second order differential equations, or of that matter any order of differential equations. And finally, you will have a concentration as a function of time. You may need to integrate something in order to see that how much of dissipation has occurred, or there are these various things. Mainly it's about the concentration of different chemical reactions. So in chemical engineering, you'll be talking about chemical reactions, and these reactions, the mechanism of reaction, how it proceeds. If you can write down an equation, that equation needs to be solved, and when you need to solve that equation, you resort to numerical analysis. Okay. Or even sometimes you may want to actually do a simulation that is very hazardous to do in the lab, some kind of an exothermic reaction, which say, for example, emanates a lot of heat or poisonous gas, say for example, and that can be done in a computer. So without actually doing the experiment, if you want to know the outcomes, such experiments are being done in a computer, and which is much safer. It just requires your computational time and your ability to code a certain reaction. So it's all over chemical engineering that is there. Panel means that basically the segment in the trapezoidal groove. So basically, it's the a given curve you have fragmented into different panels, which means different parts, and so each of these panel is like a part over which the function has to be integrated, and then you add all these contributions from all these parts, and then get the full integral of the function or of the integrand. So panel is nothing but the part which you have chosen to fragment the entire integration between the limits b to a, or a to b rather. Thank you very much, Selvaraj. It was intended to be from basics to advanced. So the most of the course covers numerical methods, and it's only towards the end that it talks about simulation techniques. We discuss two very important simulation techniques: molecular dynamics and Monte Carlo. So thank you very much. Maybe sometime you can enroll yourself and do the full course by writing the exams, etc. Will your answer sheets be checked in any college? No, 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 no. We will check it. I, along with my TS, will be checking the answer sheets. Not in any college. The exams may be conducted in in some college because it's an offline exam. Please ask for clarifications of anything that you may have confusion with. So if there are no questions, we'll wind up in about 4 minutes. Two more minutes. Please ask questions, or we shall wind it up. There hasn't been a question for quite a long time. Well, there hasn't been any query for the last maybe more than 10 minutes, 10, 15 minutes. So if there are no queries, then should we wind up? We'll just wait for a minute more. If you have any questions, you could ask, or else we'll wind up here. In any case, I want to thank you for taking this course, going through the tutorials, and finally, taking the exam. You will. I hope you'll benefited from the course. The course contains numerical methods as well as simulation techniques, and it's a course which is designed for everybody. So all these integration techniques and differentiation, and all these other things such as solution of differential equations, and interpolation particularly. So if you are in any branch of academics, you would be benefited from this course, and the latter part of the course contains simulation techniques which are slightly advanced ones, but then if you want to actually simulate a system and want to understand how a phase transition is brought about, either it's too expensive to do it in the lab, you can do a numerical exercise of that, and I have discussed 2 such methods for this. And I believe that it will be helpful, if not now, sometime during your studentship, or even if you want to take up research for your future career, it will be quite helpful. With that, I end this session, wishing you all the very best for the final exam, and stay safe, stay well. Thank you.